All right, so here's a little warm up for you. It's I wrote the equations on the right. We'll talk about them in a second, but just try to work out what K is kappa is for curvature.
And I wasn't doing that, so I was getting like some crazy numbers.
I adopted your philosophy of leaving it on screen.
No, it's
It makes it so much neater.
Or cosine 2t, because I was trying to apply it.
Never mind. Here's the one that I see. Wow, it's obviously double. It gave you no K value.
Well, did you record it, sure? You guys?
I did hit record, yeah.
Some of the device control I wanted. Tried to look at more kind of stuff, but like,
Dude, I know I was reading and I was like, why does it go hardware?
I'm gonna zero you out.
1 to 0. Which one was it? It was like the part of the velocity.
Oh, okay, you guys talking about?
Yeah.
What homework are you guys doing?
Here, we're studying for the previous exam.
Yeah. I haven't even started that. I should have started that. But I was doing the homework. This is.
Dude, but it's kind of a lot, huh? It's like 4 problems. The homework revision is a lot.
10? Yeah, I got a lot of it done on Friday and Thursday. I got like 1 problem done.
Yeah.
So now I only have one. I have like the boat problem, like part of it, part of the boat problem.
Oh, nice. That's good.
But I need to study the maximum.
I know.
Purple.
Same here.
Ooh, purple.
I was being done.
I didn't even drop out. I was like, I was guessing at something very good. Oh, yeah, man, just that was sure. It's like so far.
Yeah, I did the hard part for you. I got started.
Oh, yeah. Yeah.
That is the first step for every single option you have. You have 3 options on how you want to calculate kappa.
But you thought.
No, yes.
Yeah, I just gonna show you so rich I always think like working.
Yeah.
Kind of news, but each every
Oh, yeah. What?
Yeah.
Why is it such a struggle?
I don't know, it's great.
You should have screenshot it from your phone on the tablet.
He did it all just for you.
I appreciate it. That's a real dog right there.
Yeah.
Oh, what?
So what path should we take?
Yeah, like 18.25.
Hey, Lawrence, which approach did you take, Lawrence?
Well, I started doing the cross product, and then I was gonna divide by the magnitude cube.
Okay,
on Calc.
let's do that. Let's do that one. I like that one too. I'm being lazy. How do you like that, Brandon? I'm not listing my arguments for anything there. Not my sign, not my R's. I'm a rebel.
Rebellion.
I mean, she also said that an easier way to do cross product is, since you already kind of already have it lined up. You just put the ijk just above the -4 sine t 4 cosine t1, and then you have your cross product because they're all lined up already.
Yeah, but my RT was in the way and I didn't want to. Yeah, I do that too. You'll see me do it in the lecture videos. Where was I? J. So plus 4 cosine there, but there's a minus on the outside. We'll address that in a second. And here I got 16 sin squared.
Did you say sin?
Did you just?
I did say I did because I'm being a rebel. So that's R prime cross R double prime.
Could you move the board up a little bit? You got
Yeah.
there you go.
That's something else.
So magnitude of said vector we've got 16 sine squared t plus 16 cosine squared t plus 16 squared. And a root. Notice it loses time dependence. This is 16 plus 16 squared. Which is, I can factor out a 16 and that'll become a 4 on the outside. 1 plus 16 or 4 root 17. And then we take a look at our prime, and you take the magnitude of our prime. And that's similar. That's just root 17.
Okay.
So am I just like happening to notice only just now, or do you just like never dot your I's in your signs? Starting to notice that.
That's
Or you
way
just-
too much work. Yes, I'm lazy. If you haven't figured out I'm lazy, if that's your indication that I'm lazy, how are you? I've met you in person, Brandon. I know you know that I'm clearly a lazy fuck. Jesus.
Maybe it's because I just happen to be just as lazy, so I just never noticed. Because I think it's normal. Well, I want to know if I actually dot my side.
Not particular about this. No, I definitely can't. You go, should cross at right angle. I had like loaded it up, but I was looking at everything else cross at right angles. It's for the.
Is it everything?
I thought I fixed that.
Everything,
Like, the solid numbers correct, but like the decimal points are off. Like, half the last two are off. I think it's we did, we did this.
And then he said minor issues. Oh, yeah, and then he said I didn't label my directions.
Oh, I do dot my signs. I'm a little less lazy than I thought.
Said I put one head in the
You
end
did like the inside curve, like, how
for the second part.
like comes up, and you do like
The inner
out-
circle.
Yeah, you do the outside circle and then inner circle and then like the outer. I think it's outer.
Incorrect constant. I'm not sure. I don't know how that works.
Just because when we did it, I didn't see the being checked.
What?
I don't know.
Homework, I guess. Or be ready
And at the end, it's solid. Yeah.
I redid it too. He's like,
Change the decimal.
and then the graphic said should line at the top.
So wrong.
Yeah, well, his is off too. though.
Oh, yeah?
So like, if it was maybe.
So the bees don't like it.
Yeah.
For the
said
second,
my-
third one.
Does
Does
anyone need this up longer?
Why would I bring?
It doesn't look like it. They just seem too too preoccupied.
Yeah, they do look a little preoccupied. Let's take a look at where kappa comes from. I think it might be easier to remember at least part of it. If you can reason out where they got the formula. And it starts with kappa of S. So kappa of S, if we draw like some curve. And we have some tangent vector on there. So we'll say that's at T naught.
Team one, I got.
If we look at the tangent vector in terms of not T, but S, we have little units going along the thing. Like say these are S equals 1 unit apart. And so dt ds is measuring how much does tangent change as it goes from T1 to T2. dt ds is a change in tangent line over a change in arc length. And so I think that kind of like how much did this tangent vector change over one step? If we did it over a longer one, like I did from here to here, we could see that the tangent vector goes quite a bit is a change. I don't know, T3, 4, 5. So it's got a decent amount of change from this vector going like that and this vector going like that. And since it's in terms of how far we've gone, it's kind of measuring how much we're curving away from where we started. So I think that's like how much did my tangent vector curve as I went from, let's get rid of this T2 one. As I go from T1 to T5, my tangent vector had to curve while I was going along. So I think that's an easy one to like at least understand visually what's going on. Because that makes sense. That it's like the road's curving, or you're in your car, as you curve, it's almost like that curvature is like a measure of that force you feel going straight forward, and it kind of is. That force going forward is your velocity in the forward direction. And as the road curves, if the road's super tight, it's a pretty strong force, and the curvature of the road is pretty high. So they're kind of correlated. They're not, spot on. Velocity is just R prime. Velocity is just R prime. But then that's related to the curvature of the road kind of thing, that forward motion you feel when you're curving, your tendency to lean. But R prime is related to T. R prime is part of T. We use R prime to calculate T. So we kind of see, like, compare to how you're in the car. The other ones are less easy to remember. DTDS, switching to the top one right there is probably the next easiest to remember, because we start with DTDS, and if you don't like S, you want to switch to DT. But to do that, I still need to end up with an S on bottom. So this is like DTDS. And then getting rid of that picture to have a little more room to write. We have DSDT. So we could rewrite this as DSDT. Nope. Vector does not go over the D, just the T. By dividing by the reciprocal. And that top one, of course, is T prime. And this bottom one, DSDT is R prime. But kappa is not a vector. We don't have vector division like that. These are magnitudes because kappa is a scalar. It's not a vector. So it's more like remembering this goes to this. Because that's where I should have started. That's what I had over here. If you want to see the derivation of that one, I made a video for it. It's kind of long. No, it's not a long video. It's just that there's a lot of steps in it that you can do pretty quickly. You just need to know a lot of the formulas. So that's where we're coming with kappa. All of 12.5 is on curvature. And kappa for a circle. For a circle, I don't know why I wrote 4 with a K. For a circle which has constant curvature, kappa equals 1 over, I'm not going to use R, but it is a radius. I'm going to use like the spherical coordinates radius, 1 over rho, where rho is called the radius of curvature. And I'll show you why in a second, why we call it radius of curvature. Hopefully some of you have watched all the videos for 12.5, so you've seen it. But I saved my Desmos presentation for one of the problems.
Mr. Jones.
Yes.
What date specifically are we looking at for this chapter's test?
Tomorrow. No, not this Wednesday, but next Wednesday.
Next Wednesday?
Yeah, and if you need the date, what is that, the 28th?
Yeah, 28.
Perfect. Thank you.
Oh, I can see the calendar right here. Look at that, 28th. We will do a review this Thursday, and of course, I will do my nice long Starbucks sessions this weekend. What are you guys gonna do when you have to go to another class where your teacher isn't as cool to sacrifice this weekend for you? I just don't know.
You're gonna suffer.
You're gonna stuff her. You're gonna go, Mr. Jones, are you free this weekend? And I go, I am free this weekend. Now I'm gonna spend it playing video games, suckers.
What? You don't know how to do differential equations? And you're
I
a
know.
math teacher?
I didn't say I didn't know how to do differential equations. I said I didn't want to do it on the weekend.
But aren't you supposed to enjoy math? And you're supposed to like do it for your free time too?
Well, who do you think, what math teacher do you think does this?
Get a whiteboard like.
Math teachers enjoy the subject enough to share it with others, to share our passion with others. But in that process, we kind of lose some of our own passion along the way, because not like you guys, a lot of the classes we have to teach, we get people that, how can I put this politely, are as dumb as rocks. So we're like, we're stuck teaching people that don't like math, that walk into the math class going, I hate math, not just dislike, but I hate math is the words they like to use. And so we're stuck teaching, most of our students are like that.
Taste in math. My math is okay.
And this is
All
why
right.
this is why you can tell when you see a high school teacher, you think you can tell that they should have been in a college class instead.
Oh, look at Ben sucking up. Good job there, Ben. I can't even imagine. Wait, hold on. There's a couple of can'ts. There's a couple nots in there. I can't even imagine not having, that's a double negative, which means you can imagine having a cool teacher like me.
It was a trick.
That's okay. It's still, I'm a cool teacher, but he's imagining another cool teacher. All right. So what is this magic picture I'm talking about? So radius of curvature, where is it? Here we go, right here. Let me move that right there. We start with the ellipse here. This is the one I do in the video. And we're doing it as a function of the angle. So in the video, tangent is the angle that we're making. It's like an argument for cosine and sine. So when t equals 0, we are over here on like this point right here. And so we got a curvature of 2 over, curvature was 2 over 25. So 1 over rho, flipping that upside down to find the radius of curvature is, that's not the right one. For that one, we got 5/4. When we flip 5/4 over, we get 0.8. This is that one right there. And so the radius of curvature at this point right here is 1 over kappa. Kappa is 5/4. This is 4 over 5. And it represents a circle that has the same tangent line right there, what radius it would have to have the exact same tangent line. Notice if I make this radius any larger, let's say I make it 1 and shift this to match. Nope, let's go the other way. Let's try going all the way the other way. There we go. The tangent line doesn't, it's not quite the same. It's too big. It's close. It's too big. Shit. Where was it? 0.2 and 0.8. And then if I go to where t equals pi over 2, straight up right here, that's where the radius or the curvature was 2 over 25. So flip 2 over 25 over, it's 25 over 2 or 12.5. So that's my R. We're looking for a circle that's got a radius of 12.5. This stuff up here is just to line up the circles. So when I turn it on, we can see the curve just meshes nicely with it as it's coming in. It matches up just nicely. The tangent line at this point is the same tangent line. And when I did it with this circle over here, they have the same tangent line right there. So that's what they mean by radius of curvature. The curvature at any point doing the reciprocal would be the radius of curvature. And it would be what would a circle with that radius, or what circle would have the same tangent line? It'd be a circle of that size radius. So that's what they mean by radius of curvature.
Nice.
Okay. So does that make sense? That's why they call it that. Cool. Let's take a look at another problem.
That has the radius that matches.
Drag a little bit of my lectures in here because half of you aren't watching the damn lecture videos. I'm not doing the full presentation here, but hitting the highlights. Where is my picture? There it is. Let's do the same thing here. As a reminder, we have options for kappa. Who wants to do DTDS? That doesn't sound like any fun. It's not a regular K, it's like a crazy looking K. That's how the book kind of does it. You got DTDS, magnitude, these are all magnitudes. We have T prime over R prime, and these are in terms of T. And we have that cross product one. You have options.
Options indeed. That's the really doesn't like options.
That's really hard to really pick up.
It's an even harder integral. Only hard problems here. Lawrence. We're here to challenge you.
No, I'm here to teach you. Quinn's here to fucking challenge you. They're showing me their physics 2 homework. Physics 56, their homework is what we're going to do in like the last 3 weeks of class. And no. They're digging into what we do in the last 3 weeks of class, where we do triple integrals with spherical coordinates. He kicks it up a notch by making it the interaction of two bodies, a little tiny human and the planet. So he like super complicated triple integrals in spherical coordinates for a class that he knows hasn't learned it yet. I need to talk to that.
Sounds fun.
This is why I do not. I never wanted to
What
take.
he's gonna tell you is, to be fair, it's extra credit and we're not required to do it. That's what he's gonna tell you.
Yeah.
Oh, I didn't hear all that shit. You all keep asking me for help like it's homework. Eric giggled almost.
It
Eric
was
almost
homework.
giggled when he said it. Okay, like Mr. Jones is here, but this was yesterday. I'm going to distract Mr. Jones by having him help me with physics. And he was smiling while he said it. And how much work did I get done after that, Eric? None. We spent like an hour and got nowhere on that fucking problem. I got no work done.
You'll be happy to know that we solved it.
Congratulations.
Did you? Good, because I want to see the solution.
They solved the first part, the use of by our computer website.
Oh, gosh.
And
So you didn't solve shit.
I want to see the problem. That sounds cool. That's a.
It's a neat problem, but it's like the purpose was to derive the gravitational force formula. Why?
God.
We already fucking have it. We don't need to derive it.
I'm gonna tell you that next time you drive something. It's gotta be pretty.
No, that's different. That's different, Lawrence.
There's a difference.
I'm showing you where it came from so that
It's
you can
easier
do
to
it.
understand.
Not showing you. He's making you pull it out of your ass like a rabbit out of a hat.
Well, it practically is a magic trick at this point.
Right. I'm showing, he's telling you to do it. Without guidance and with using mathematics, he knows you don't know how to use yet.
That's why I'm waiting to finish my calculus classes before taking my next physics class.
That's a good idea.
56 next semester.
Because I took 55 with Calc 2 and it was difficult. It was so difficult. There was like, because like, just like topics would just be separated. They're like not taught together. And like one side would be feel like it'd be missing.
Yeah, normally people want to-
And then I hear for in physics 55, the first lab has partial derivatives in it. Again, we haven't covered partial derivatives yet in Calc 3. There's no reason for it to be the fucking first lab in physics 55.
Is it really?
That's what they were telling me.
Was it? Was it? I don't think you have to.
Because there wasn't a normal after.
I couldn't say anything because my lab that class is online, so we had a different set of class, which actually were really fun.
I heard like.
Like I saw something with like.
Dude, and it's just jumped up.
It's still like, it's still like over like 80 pages, right? Or I mean like.
What's that you got there, Mr. Jones? Very interesting matrix you have there.
It's not a matrix. It's my super duper awesome sauce.
Why do you still have the brackets?
No, she took the derivatives and
I
then
know,
just
I
put it
know,
on
I know.
top.
I know.
I put the cross product matrix right on top of it so that I wouldn't have to rewrite it. To do that, you have to compensate and give yourself some space between R and R prime. That way you have room to write in IJK afterwards. That's your pro tip.
I love writing with my
This
fingers.
pen is dying. That makes me sad. Oh, here's that color that's gonna look ugly. Brown.
At least you can see it. Oh, not the fingers.
Forgot to bring his pen. So I guess write it with his fingers. To be honest,
It's not that bad. It's just like it's annoying. Not that bad. It's annoying. It's annoying, but it's like it's manageable. My tablet isn't even. Oh, it's not bad. I'm not
That's where I'm
suicidal.
getting the ones. For those of you that are not up on your exponential algebra using exponents,
That's zero.
That is e to the 0 d.
minus a negative. So minus a negative will become plus. So our vector for the cross product,
Aristotle. I'm not that close. One is not zero. He lives in my room. Was that like brown? It's like pockets. They don't exist. It's like turtles. They're not real.
So I sat there for like 2 hours.
It was part of the first divergence.
I did it.
Did you do any of the other?
I read it first. I did it once. I was like, I don't know why. So I did it. And it got the same thing.
Yeah. Did you do any of the other parts?
I just wanted to finish that.
Right.
Yeah, I like
so I think
Other way,
Ben
like
was
bulb.
asking me about a problem like this. The cleanest, remember e to the negative 2t is 1 over e to the 2t. So maybe we should try to clean this up a little bit, not leave it like a hobo.
Hobo legend.
By finding a common denominator. So we need to multiply these two by e to the 2t, which would make this
He uses like, he doesn't use one, he uses less electricity. I use your like. It's not very nice. No, you said. I love thinking about it.
and what is e to the 2t times e to the 2t?
E to the 4t.
It's e to the 4t. Like 40.
And then after W. All right, I'm so behind. He's already on like the 55 million. W. It's nighttime.
It's pretty cheeky of you doing it that way. That way you can easily put it into the vector itself.
Yeah. I'm clever like that. We're not done though. That's just the
Yeah.
magnitude of r prime cross r double prime. So maybe I should write that.
Oh, yeah. It's still need to pack
Wait, is it R double prime?
Oh, that magnitude, that's the magnitude of the cross product.
Already?
So what was r prime? R prime had, it was similar, but we didn't have a, r prime looks almost identical to this right here, but instead of having a 2, we have a 1.
Oh, now he's doing the magnitude.
Hey, Lawrence, are you gonna tutor 56 next semester? No, yeah. Make sure you keep it on.
Physics 6, you need physics.
Oh, you did a tutor next semester? Semester? I'm gonna need help anyways.
You said 85.
No,
No, you said.
Well, I'm gonna get fired.
I mean, same though. I don't get enough students, so who knows if they'll let me go.
What's going on next semester?
Oh, no, before he got fired, I'd probably scare off all his students.
Yeah, probably.
God, this has gotten ugly. I need another board. While you
Well, I
guys are
mean-
writing that, I'm gonna copy what we got here onto another board so we can finish off Kappa.
Actually,
'Cause
that
we're
doesn't- that's actually not all that bad, looking at it. Those two bottom e to the t's cancel out.
Title.
Well, we cubed the r prime one though. It's not going away.
Oh, you're right. You're right. That means, so do that, do that. Oh, so the e to 3t is at the top.
I'm gonna write that as e to the negative t out front rather than one doing. I think that's easier. Oh yeah, this will look a lot better.
Wait a minute, I'm. Wait a minute, it's hard.
Yeah.
Wait.
Wait, are you writing something? Because it's not showing up here.
I think I'm.
No, I'm doing it on another board. I'm gonna put it up on the screen. I'm waiting.
Oh, okay, just making
I
sure.
want to make sure everyone's done with what I have there before I just start replacing shit.
Multiply the things. What's the cost of it? That would make sense.
Already. Get all the way down there.
So I rewrote R prime cross R double prime. I rewrote the magnitude of R prime cubed. We're dividing by it. We gotta kind of see what cleans up. So what do we got here? We're still gonna have an e to the negative 2t on bottom, right?
Trying to think.
I'm gonna call this top part square root of a, and this part is square root of b, at least for the initial steps right here. We end up with square root of a over e to the negative 2t.
If you multiply these, you get 0. You multiply anything by 0, it just gets 0.
No, 0 and 1.
It doesn't matter what you multiply it by, it's gonna be 0. How did he get anything?
You must have done the cross product wrong.
Isn't it just? Oh no. To that.
Yeah. Yeah, I bet your cross product's wrong, Jericho. Nothing really cleans up here a whole lot, does it?
What?
Yeah,
Doesn't look like it.
This was like a 2 by 2, maybe I think, maybe we were thinking about. This is a 3 by 3.
You just cover that and you go like that and like that, and then cover that, you get that.
We move the e to the negative 2t to the top.
You cover that, it's that, and I already got all things, that's what I get stuff like.
And I don't know that I don't think I want to, that is b root b, but I don't think I want to write it like that. I think I'm just gonna leave it as the radical
There's that.
Sit up there,
cubed.
That is IJK.
Wait. Well, you don't have it set up down here. It's not set up in a vector form.
You mean down here?
Yeah.
Isn't that, what do you mean vector form?
Well, when you cross two vectors, you just get another vector. So you can't just add them up like that.
Right here? Isn't that how we are prime cross?
No, after we find the cross product between those two vectors.
So then we're
we
not-
find the magnitude, that's when we solve it.
0, 0. I don't even know what you mean by a vector form.
No, I'm driving.
Oh, drive.
I don't remember.
He's a jump.
Getting a vector form and doing the cross product.
You need to check that. So when you understand why there's an IJK,
Yeah,
that's signifying that I am talking about.
Oh, yeah.
The I
Jump
part
to
of
the
the
second
J signifies J part of the vector. When I did the K, it's signifying the J part of the vector. I did it, which should signify that it is a vector. But it's
How would you read it vector?
well, yeah, so you know, I create a normal vector, a vector that will,
I never.
Yeah.
I don't know, I never. Like one of my, someone's.
Is that what that was? The ukulele? The guy who's oh, yeah.
It is.
You tell he's like,
sad.
So,
Does he know? How do you change that to your background?
Well, that's why you have to work upon now. You look at it, sir. And then you just try to work it out.
You guys have any questions?
what if you can't look at it? So how are you gonna do that?
Well, then you just. Hope for the best.
What are we,
I said, what are we working towards?
Like I already said, I fucking wanted
If
to.
you're talking to me, Lawrence, I can't hear you. You might have to come up to the camera.
No, yeah, no, they be gapping up.
Never mind, I'll ask him because.
You said, well, we working toward it.
That's fine.
What?
Yeah, like, don't worry, it's gapping.
Like, what are we working towards with this? Like, it seems like almost like if somehow we're gonna get towards integration, but I don't know how it would work out.
This is the end. This is the end. We can find the curvature at any time t. So like t equals 0.
Like the 4 out of 5 pencil, it's all the same shit anyway.
It's expensive.
No, it's fluorine, that's all that matters.
What would happen if we like, what would happen if we integrated KFT over like some time interval? Would that just give us the curve or would that like give us like something close to the curve?
Serious, like,
Integrate, if you integrated kappa over like time,
Yeah.
Toothpaste.
That's what I thought we was getting towards, but maybe I.
no, we're not. No, kappa is where it ends.
Go back to where.
What's that?
Brush your teeth.
I don't know that integrating kappa over time even makes sense.
It's like it's really.
No, it is. It is part of the, each part of the, you have to leave it for a while. That's a.
Yeah.
Yeah.
That's
Like,
a good one.
Like,
You wait for a while and then you do it. You wait, oh, wait.
There's no breath about it.
And then you.
Yeah, it's just a cross run.
Oh, so should I do record?
And then my board.
Yeah. That's what I was thinking, that's how it was.
And I think the reason why is they meant.
Oh, wait, was that right though? Minus 0, because you multiply them.
And maybe when you cut your.
So that's part of the, that's.
Oh, I'm gonna use that for,
Yeah.
yeah, finding the
IJK.
role.
Dude,
The radius of.
How do we? Oh, no.
So here, row of at 0 would be 3 over root 2. We flip it over. And so that would be whatever that curve looks like. Like if the curve looks like this, there's a circle that matches up with it that has that same, wait, that pen doesn't work.
Basically.
Has the same tangent as this
I don't get the message.
round curve right there.
That's what he was talking about that. And the same thing will happen.
That is a terrible looking circle. Look at that sad looking circle. That's like a lump of dough. That's terrible.
It's still.
So that was. So.
All right, it's 9 o'clock. I'm sure you guys got places to go. We will look at this some more. We'll also start 12.6 tomorrow. We'll do a review on Thursday. So we're almost done with this chapter.
All right, see you, Mr. Jones. Have a good one.
I don't know where he's having.
You have a good one too.
They're both negative, I guess. So they, I guess.
I think that no, they're expecting the future today. Yeah.
Dude, you won't believe it. But I doing the same thing with my other one.
No.
They're breaking the same spot. Keep like just around everywhere. You're breaking my.
Breaking with dog.
This ain't keep
Which is. Yeah. Yeah.
I'm gonna do it. I'm gonna tuck my shirt in, wear the belt, like wear the flannel. I'm gonna part my hair, make sure it's nice and.
Wait, you're gonna wear a plaid plan? Are you coming in as Dr. O?
No, I'm gonna be coming as Quinn because it's scary. He's scary.
Oh. Have a good day, guys.
Yeah, you too, Professor Jones.
What is your name? I keep forgetting your name.
Zach?
Zach. I've
Yeah.
had Zach in my head, but I'm like, there's two Zachs, I think, in the class. It's
Yeah.
still, we're still,
Yeah.
Jericho, did you get cross product worked out with Brandon?
Oh, yeah, I was getting, I guess, I don't know what was going on. I wasn't doing it right.
Yeah,
I was like-
I knew you did,
I was
were doing
doing-
it wrong earlier.
Yeah,
I was
what,
doing it like the dot product where you like, you just add them all together, or you must. subtract it,
yeah,
you also-
he didn't realize that he was supposed to get a vector out of it rather than a scalar.
Right.
Maybe it's because we were trying to get the magnitude, so I just.
Yeah, but that probably might have confused you as well.
Right. I could see that. All right. Have a good day, gentlemen.
All right, you too.
All right. I have nothing else on my end, so I'll go ahead and be going.
Good. All right. Any questions from the gallery at home? Ben, you
Nope.
good?
We're good.
All right.
Well, I'm not good,
But yeah, I
but
know
on the
you-
math front.
I hope you feel better.
Thank you. Well, see you tomorrow.
Okay.